Welcome everyone. In this video we are going to take the squares of even and odd numbers and we are going to make a generalization about their squares. So let's say that we have x, which is an even number. Then what can I say about x? I can say that x can be represented in a way that I have 2 times n, where n is defined as a integer. It is the element of the set of integers. This capital Z means the set of all integers. It contains any integer that you can think of. Think of an integer, it is in the set. Well, I want to take the square now, because as I said, we are interested in the squares of even and odd numbers. If I take the square of both sides, I will have x squared is equal to 4 and then n squared. Well, what do I see? I see that no matter what the value of n squared is, whether or not it is odd or even, I will multiply it with 4. And 4 has a factor of 2 in it. So x squared is automatically an even number. I hope this makes sense. What I claim is, since I show that x squared is equal to 4 times n squared, x squared is an even number, because whatever I substitute for n, since I will multiply its square with 4, I will get a product that is a multiple of 2, and that is by definition an even number. Okay, so we show that x squared is even. Then what about the case where x is an odd number? X is odd. So perhaps if I take the square of an odd number, will I get an even number, an odd number? Let's see. So x is equal to, we can represent an odd number as 2n plus 1, where n is again an element of two integers. If I take the square again on both sides, I will have x squared is equal to 2n plus 1 squared. And if I expand the square, I will have 4n squared plus 4n plus 1. And you can check that this in fact is correct. Okay, I would suggest checking that if you don't agree with me. So what do I see here? Well, I see that I have an even term. This 4n squared is even because using the same logic that we just applied, no matter the value of n, so no matter the value of n squared, we will be multiplying it with 4, and 4 is an even number. It has a factor of 2 inside of it, so the result will be a multiple of 2. It will have 2 as a factor. It will be even then. That is the definition of being an even number. And for 4n, obviously the same result applies. It is even. And 1 is odd. Of course it is odd, right? It is odd. And realize, if we have an even number, so these two are even, when you add two even numbers, that will give you an even number. And even if you don't want to think of it like that, hold on, let's not do that. So if I divide this right side by 2, I can divide this one, I can divide this one, because they are even. That means they are divisible by 2, but I can't divide 1 by 2, because it is odd. Which means I can't divide this whole expression by 2. When I do that, I don't get an integer. Which means this right side is not even, it is odd. So I get that x squared is odd. So what does the result tell us? It tells us if the square of a number is even, then the number itself is also even. And if the square of a number is odd, then the number is also odd. Okay, when you square an even number, you get even. When you square an odd number, you get odd. This is a very simple and easy proof to make, you might be saying to yourself, and it really is, but in a future video we will use this to prove that the square root of 2 is irrational. So stay tuned for that, and I hope this video was helpful. This is it for this video. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care. Welcome back everyone. I know I ended the video, but I realized a mistake that I just made. A minute ago, and you can rewatch it, I said that we proved if x squared is even, then x is also even. Well, no, we did not prove that. We only proved that if x is even or odd, obviously, then x squared is even. This is what we proved. However, a minute ago I said that we proved that we can go the other direction. Well, no, we didn't prove if x squared is even, then we can conclude x is even. We only proved that if x is even, then x squared is also even. Okay, we did not yet prove that we can go from right to left. We only proved that we can go from left to right. And we actually, in fact, can go both directions. And I will prove that we can go both directions. So this is a biconditional statement, okay? I hope this clarifies if there was a confusion. So anyways, take care again.